Welcome to CSIR NET Chemistry Facts. Hello guys, today we will discuss this question CSIR NET December 2017 part B, question number 39. So this is the compound A is given and which one is the most stable conformation we have to determine. So there are 4 options. So we'll go for the Gilles mechanism for this. Hello guys, so this is the given compound in our question. So this is a 1,4 substituent for the 1, 2, 3, 4. So here you can see this both substituent are in the above bond, so therefore this is a cis structure. So guys, 1,4 cis structure for a cyclohexane ring is possible if the one substituent will be the axial and another will be the equatorial position. If both in the axial position, then that will be a trans geometry. If both in the equatorial position, then that will be a trans geometry. For both, so for one is axial and one is equatorial, is give the cis geometry. So this is the condition to get the cis geometry, and this same rule will applicable for the 1,2 substituent as well. But guys, this rule I don't want to remember, and I want to describe this one in the terms of the alpha and beta bonds. So what is alpha and beta bonds in the cyclohexane ring? So whatever the bond is the below direction is known as the alpha bond, and whatever the bond is the upper direction is known as the beta bond. Okay, so below direction is alpha bond and upper direction is beta bond. So here also the upper direction will be known as the beta bond, and below direction will be in the alpha bond. So this alpha bond may be axial bond, alpha bond may be a equatorial bond, and beta bond also may be axial bond, and beta bond also may be a equatorial bond. So guys, how many beta axial is present? So this is 1, and this is 2, this is 3. So 3 beta axials are there. How many alpha axials are there? Alpha axials are there. So therefore this is 1, this is 2, this is 3. So 3 alpha axials are there. Now how many alpha equatorials are there? So this is 1, and this is 2, and this is 3. So 3 alpha equatorial are there. And now beta equatorial, how many is there? So this is 1, and this is 2, and this is 3. So 3 beta equatorial is there. So guys, every bonds are present in 3 numbers. So guys, now we have to remember that if the both bond are in the beta or both bond are in the alpha, then this is the condition for a cis geometry. And if one is alpha and one is beta, then it will give a trans geometry. So in our question it is given as a cis geometry. So therefore we have to see that both should be in the beta or both should be in the alpha. So in this case 1,4 position, if both should be in the beta bond, then one should be equatorial and one should be axial bond. So guys, I will come for the question answer now. So guys, in the option 4, so I will start from the option 4. In the option 4, what is given? This compound is given. So here you can see this methyl is there in the axial bond, and this O is also there in the axial bond, and both are in the axial bond, and one is upside, so upside is beta, and one is below side, that means that is the alpha. So therefore this is a trans geometry, right? But our given compound is a cis geometry, and hence this is not representing our given compound, and hence option number 4 is cancelled out. So if we flip this ring, then we will get this structure. So in this case you can see this methyl is in the equatorial plane, and this OH is in the equatorial plane, equatorial bond. So in this case this methyl is the upside, so therefore this will be a beta, and this OH is in the below side, so this is the alpha, and again it is the trans structure. So this is also not our given compound, and this is given in the option number 2. So option number 2 is trans structure, and hence this is not our given compound. So this also cancel out. So now we will come for the option number 3. In the option number 3, what is given? In the option number 3 is given this one. So in this case you can see this methyl are in the axial position, and this OH in the equatorial position. In this OH also in the alpha bond, OH also in the above side, so this is a beta bond, and this methyl also in the upper side, so this is a beta bond. So both are beta bond, that means this is a cis geometry, and our compound also is cis geometry, so therefore this is representing our compound. But this is a most stable structure or not? So for determining this, we have to consider the 1,3 diaxial interaction is happening between this methyl and this hydrogens. So this diaxial interaction will make the system unstable. Why it is 1,3? Because the interaction is between one substituent and the 3 substituent. So therefore it is known as the 1,3 diaxial interaction, and this diaxial interaction will make the system unstable, and hence this is not the most stable conformation. Okay, and hence there is so this is not our correct option. So option number 3 also not our correct option. So for getting our correct option, we have to flip this ring. If we flip this ring, then in that case we will get the option number 1. So this option number 1 is this one. So this is the option number 1. You can see here methyl is in the equatorial plane and this OH is in the axial plane, and here both is in the beta position. So both is beta bond means this is also a cis geometry, and this is a cis geometry means this is our given compound is also cis geometry. So this is representing our given compound. So in this case you can see this methyl does not have any steric interaction with the 3 position hydrogens. That means there is no diaxial interaction because these both hydrogens are in the opposite direction of this methyl in this case. So therefore there is no diaxial interaction with this methyl, and this OH also cannot go for a diaxial interaction because in this 3 position 1 2 3, in the 3 position there is no CH2 and oxygen is present, and hence there is no hydrogen is there for the diaxial interaction. So therefore in this structure no diaxial interaction is present, and hence it will make the system very stable. And one more thing is that this OH can be representing like this, and here you can see there is a hydrogen bond between this oxygen and this OH. So this hydrogen bond will make the system more stable. So this hydrogen bond will make the system more stable. So this for this hydrogen bond we will get this conformation is the most stable conformation. So guys, option 1 is the most stable conformation because of this two reasons: no diaxial interaction and hydrogen bond will get the extra stability. So option 1 is the correct option. So guys, option number 1 is the correct answer, and option number 1 has the hydrogen bonding with this OH and this 2 oxygen, and therefore there is no diaxial interaction, and hence this is the most stable conformation. So option 1 is the correct answer. Thank you so much for watching this video. I will come for the next video tomorrow. Please like, comment and subscribe this YouTube channel.